Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question which is product of array except self. So in this question we are given an integer array nums and we need to return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. So and the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Means we don't need to use any sort of long 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 data type in this question. We can just use an integer. So when we are performing the multiplication of elements, they will fit inside of an integer. So that's what they're saying, and you must write an algorithm that runs in order of n time without using a division operation. So this is the most important thing. We cannot use the division operation, right? So so let's look at some examples. Suppose if you take this example, initially, suppose if we are at this index, we need to find the multiplication product of all the remaining elements, which is 2 into 3 into 4, which is 24, right? And then suppose if I'm at this index, I need to find the product of all the remaining elements, 1 into 3 into 4, which is 12, right? And when I'm at this index, I need to find the product of all the remaining 2 into 4, which is 8, right? And when I'm at this index, I need to find the product of remaining all elements, which is 3 into 2 into 1, which is 6. So we need to return this array. So we can also go through this, but I guess you guys understood the question. And let's look at this example. How are we going to solve this using a basic approach? Let's say an approach one. It's a brute force approach. In this, we are basically going to do. Suppose I'm at index 0. So what I'm going to do is I'll ignore my index. I'll ignore the index which I'm currently in, and I'll take another pointer, which ignores the index that I'm currently. Suppose this is I and this is j. So this jth index ignores the ith index and finds the product of remaining all elements. Right? Initially j will be here. Initially j will be pointing to this, but it will ignore because I and j are equal, right? And it will find the product of all the remaining elements. It will be 24, right? 24, 24, and then my j will always start from 0, right? This is j and this is I, and j will find all the remaining elements except I. It does not include I, right? So 1 into 3 into 4, which is 12. 12. And when I comes here, j will ignore this and it will be 1 into 2 into 4, which will be 8. And when I comes here, j will ignore this. It will be 1 into 2 into 3, which is 6. So this is our resultant array and we need to return this. So let's look at the time and space complexity. The time complexity will be for every element we are going through the entire array, right? So there are n elements, and for every element we are going through the entire array. The size of the array is n, right? So order of n into n, and the space complexity is, since we are not using any extra space here. Here in this question, they have mentioned that the resultant array will not be considered as an extra additional space complexity. So if you if you look at this, the output array does not count as an extra space for space complexity analysis. So we will not count this as extra space. So by considering by ignoring that, the space complexity is order of 1, right? So but in the question itself, they are asking us to solve it in order of n time. But here we are taking order of n square, right? So let's try to solve it in order of n square. I'm sorry, order of n. Let's say approach 2. Let's look at approach 2. So now let's look at the second approach, guys. In this approach, we're going to solve this using order of n time complexity. So before that, let's try to analyze this question. So suppose suppose I'm at this index. So what I need to do is I need to get the product of these two elements. I should not include this, right? And I should get the product of these two elements, right? Then the product of these two elements is 2 and the product of these two elements is 20, which will be 2 into 20, which is 40. So we need to do it like that, right? 2 into 20. So let's say I'm at another index. Let's say I'm at this index. So let's say I'm at this index. At this point, we need the product of these three and we need the product of this one element, right? It will be 6 into 5, which will be 30, right? And let's say we're at this point. So at this point, we need the product of only this element and we need the product of these three elements, right? So it is 1, 2, 3, 4, 12, 12, 5 are 60, 60, right? So if you observe the pattern, if you have observed the pattern, at every index, this is 0, 1, 2, 3, 4. At every index, we're basically requiring the previous element's product and the next element, all the next elements product, right? So for this, what I'm going to do is I'll take two more arrays. With two more arrays, this array will contain my prefix product, and this is my suffix product. These elements will have the same size as the original element. 3, 4, 0, 1, 2, 3, and 4. Check another color. What this arrays contains is that suppose I'm at this index. If I'm at this index, this element contains all the product of all the elements before this. 1 into 2 is 2, right? And the suffix array contains at this index all the elements of all the elements which are towards the right of the element, which is 4 into 5, which is 20, right? Suppose I'm let's come from the starting index. So in the starting index, what is my what is my left product? I will not have any product, right? Can I keep 0? I cannot keep 0, right? Because if I keep 0, if I multiply it with the right product, it will become 0, right? That's why I cannot keep 0. For 0, the left product will be 1, and for 0, the right product will be 2 into 3. 2 for 0th index. For this index, the right product will be 2 3 are 6. We need to multiply all these elements, right? I'm gonna remove these. It will be 2 3 are 6, 6 4 are 24, 24 5, 120, right? So 0th index right value will be 120 and the left value will be 1, right? And let's look at the index number 1. If you come for index number 1, what's the product of left values without including 2? Only 1, right? So it will be 1. What is the product of right values? 3 into 4 into 5. 3 4 are 12, 12 5 are 60. 60. We have already calculated for index 2, right? So we'll directly go to index 3. So what is the product of left values? 1 into 2 into 3, which is 6, and the right value will be 5. And when we come to this index, what is the product of these? 2 3 are 6, 6 4 are 24. This is 2. And what is the product of right values? There are no right values, right? So the right values will be 1. Now, what you're gonna do is you'll just keep on. Suppose if you're at this index, what we need to do is we need to find the and oh yeah, we need to find the resultant array, right? So I'll take a resultant array which will be of the same size, which will be 0 1 2 and 3. Now what I'll do is So suppose I'm at 0th index. 0th index already contains the product of previous elements and the next elements, right? So it will be 1 into 120. It will be 120. And when I'm at index 1, it will be 1 into 60. 60, right? And when I'm at second index, it will be 2 into 20, which is 40. When I'm at this index, it will be 6 into 5, 30, and I missed another index, and this will be 24 into 1, 24. So we need to return this array. So this is the approach, guys. Basically, we're just going to find the prefix array and the suffix array, and we're going to multiply each and every index in order to find our resultant array. This is the approach, guys, and if you observe the question carefully, the follow-up. Let's look at the time complexity and space complexity before that. So what is the time complexity? I'm going to traverse this once for this, twice for this, and the third time for this. So it will be order of 3n, right? And what is the space complexity? Space complexity is we're only using two additional arrays, right? So it will be order of 2n. We're not considering this resultant array as an space complex. We are not considering this as an additional space. That's why our space complexity is order of 2n. But if you look at the question, they're asking us to can you solve a, they're asking us a follow-up, can you solve the problem in order of 1 extra space complexity? So here we're using order of 2n. And let's suppose n is some 10 power 5. The 2n 2 it will be 2 into 10 power 5, right? 2n means so it is very large. So in the follow-up, they're asking us to solve it using only order of 1 extra space complexity. And the thing that we need to note is that the output array does not count as extra space complexity. So how are we going to do this? This is our approach 3. I'm going to explain the same the approach here itself. So we're going to use only the resultant array. We're not going to use this. But since even though we are using the only one array, but we are going to use the same approach that we use it right now. Now let's look at the third approach. And in this approach, we're only allowed to use an resultant array, right? So we're going to use this array as the arrays that we use it right here, right? The prefix array and the suffix array. So right now what I'm going to do is I'm going to use this array as a suffix array. And when I'm going from left to right, I'm going to maintain my prefix product, right? So initially I'll store the suffix product in this array, and when I'm going from left to right, I'm going to store my prefix product in a variable and use these two values in order to find my resultant array. That's it. So what is the suffix array in our previous thing? Initially it will be 1 and 5, because for 4 the right product is 5, and for 3 the right product is 20, and for 2 the right product is 60, and for 1 the right product is 120, right? So this is our suffix array. And now I'll use a prefix variable. Initially it will be 1, and what I'm going to do is this one is the we already had a prefix array, right? The prefix array is like 1 comma, for 2 the left product is 1 only, right? And for 3 the left product is 2, and for 4 the left product is 6, and for 5 the left product is 4 3 are 12, 12 2 are 24, right? Now initially this prefix is nothing but this value. right? Now, what is my resultant array will become? It will become prefix into this suffix value, which will be 120, comma. Now this prefix will multiply with this value. 1 into 1, again 1, right? Now this one is nothing but this one, right? We are getting the second prefix value. Now 1 into 60, which is 60, right? 60. And now the prefix value will become 1 into 2, which is 2, right? This 2 is nothing but this value. So we're basically at third index. We're getting the left product by using this prefix array, and we're getting the right product by using this resultant array. That's it. So now 2 into 20, which is 40, right? And now we're at index 3. So the prefix will become 2 into 3, 6, right? So 6 into 5, which will be 30. And we're at index 5, right? And what is the prefix product? 6 into 4, which is 24. 24 into 1, 24, right? So this is our answer. So let's look at the time and space complexity of this before we code this up. The time complexity is uh, we're going to traverse for this result. Initially, we're going to store the suffix, right? So it will take order of n plus. Again, we're again traversing through the entire array in order to find the prefix and the resultant array, right? So it will again take n. And the space complexity is, since we are not considering this as an extra space, we're only using constant space, right? So this is a time and space complexity. Now let's code this up. So initially, as I have already said, I'll use a suffix array only, which will be the length of the given array, right? The length of the given array is n equals to dot length. Now, as I have already said, I'm going to fill the rightmost value of the suffix as 1, right? So suffix of n minus 1 equals to 1. Now what I'll do is I'll traverse from the back int I equals to n minus 2, I greater than or equal to, and my suffix of I will become suffix of I minus 1 into sums of I, right? Suppose let's let's take this suffix equals to, it will be like this, right? Initially I'll put 1 here and I'll start from here. Now this value will be 1 into 5. 1 into 5, it will be 5, right? And again when I come here, this value will be 5 into 4, which will be 20, because for 3 the rightmost product is 4 into 5, 20, right? So this will work. And I already said we'll take a prefix value which will be 1. I already said we'll take prefix value 1, which is equals to the prefix array's first value, right? And then I'm going to traverse from I equals to 1, I less than n, I plus plus, I plus plus. I'm going to use the same suffix array as my array, right? So my result equals to prefix of prefix into suffix of I, right? Prefix into suffix of I. So I'm going to update my same array with my result. And at the end, I'll just return my suffix array. I don't think this will work, because if we start here, let's try to run this. Array index is out of bounds. Oh, we need to use +1 here. Wrong answer. We're getting 1. So what we are doing wrong means we're having a suffix. Let's try to bring down the whether we're getting it right or not. Try to run it. I haven't submitted it. So this is my suffix array of, okay, I'm getting my suffix array as 6631 for values 1 comma 2 comma 3 comma 4. Getting a suffix value, it should be 1 comma 4 comma 3 4 jar 12 comma 24, but I'm getting 1 comma 3. Oh, should be nums of I plus 1. So this 1 4 4 12 24. Yeah, we're getting this correctly. And okay, I need to update my prefix as well, right? My prefix will be prefix into nums of I. Nums of I minus 1, I guess. So initially my prefix is 1 and prefix into suffix is, oh, suffix of I minus. Again, wrong answer. Okay, we're getting this. Initially my prefix is my prefix is 1, and what I need to do is my result uh, 1 into 24, and then I did that prefix 1 into prefix of I minus 1. This one, right? Start 0 itself. Take I, try to submit this. Yeah, it's getting accepted, guys, and this is the solution for this. I don't know why I started with 1. Yeah, thank you guys for watching this video.